This project uses spectrophotometric analysis to determine the mass of aspirin tablets. The origin of this project came from when I was taking Tylenol and Advil and aspirin to ease headaches, and I realized aspirin had the lowest dose amounts in single tablets, and so I could regulate exactly how much I was taking. And I began to wonder if the listed value was actually, if those 81 milligram tablets were actually 81 milligrams, which gave rise to my research question: what mass of acetylsalicylic acid, which is essentially aspirin, is present in different brands of aspirin, and is this value accurate to the printed value on the bottle? So my independent variable was the brand of aspirin, and my dependent variable was the mass of acetylsalicylic acid. I hypothesized that it would be very accurate to the printed value because the tablets are regulated by the FDA, which ensures companies are honest in their advertisements on the bottles. So the aim of my experiment was to measure the acetylsalicylic acid content of aspirin tablets. I did this through a process known as spectrophotometry, and a spectrophotometer model is shown on this slide. So essentially, using the Beer-Lambert law, the mass can be calculated using the absorbance that is measured by the machine. The calculations will be shown later, but the main material that I used was the SpectraVis Plus, and also the 3 brands of aspirin, which were Equate, St. Joseph, and Bayer. These are the 3 brands that are easily accessible in my area. They were all safety coded, and they were all 81 milligrams. So my method essentially included preparing an iron chloride solution, which raised the maximum absorbance frequency to a level which was measurable by our school's spectrophotometer. I was then able to prepare a solution of NaOH, acetylsalicylic acid, and water to mix with the iron chloride and place in the spectrophotometer for the concentration to be measured, and then that would allow me to later calculate. So the raw data can be hard to decipher because the numbers are very small. However, it is easy to immediately see that the St. Joseph is significantly higher than the other values. The data is much easier to decipher once it has been processed. So this is the processed data where I took the calculations shown on the side, and they were done with each one, but for saving space I showed an example using only the Bayer trial 1. So you can clearly see the different masses of acetylsalicylic acid, which is the active ingredient, and this becomes clear in this slide where the percent error is calculated. So as you can tell, the Equate was very accurate to what I expected it to be. The Bayer varied, but I think that was likely due to some random errors that occurred within the experiment. And all of these values for Bayer and Equate are underestimates. St. Joseph was 206% over the expected 81 milligrams, and so obviously this is highly unlikely, and I determined that it was likely due to the safety coating on the aspirin tablets because the St. Joseph coating was a red color and it was very difficult to break up, so there was a significant amount left on in the solution, so this could affect the color and could cause the equipment to misread it. Unfortunately, because the only tablets available were safety coded, there was nothing to be done for this limitation, but in future experiments it would be good to search out unsafety coded tablets. Additionally, the iron chloride solution changed colors from purple to orange to clear over time in the experiment, and this is likely due to contamination, but every effort was made to mitigate this by washing equipment in the future, you could have enough glassware to not need to reuse it and wash it in between. In summary, I believe that the equate was definitely the listed value. The Bayer aspirin is likely the listed value as well because of the 4% error shows that it's pretty accurate, and the other two did have random errors that were observed in their trials. And the St. Joseph, it's impossible to determine from this experiment because of the error that occurred there with the safety coding and that limitation.